Hello everyone and welcome. Today I would like to talk about find all anagrams in a string. The question gives you two strings, S and P, asks you to return an array of all the start indexes of P's anagrams in S. So how can we do that? In another video, I've talked about group anagrams where I introduced the concept of developing an order independent character counter of a string. If you are not familiar with that character counter, please feel free to look up this video in my channel. And here's a general tip for solving this question. Use a sliding window plus an order independent character counter of a string. And here's an illustration of how to use the character counter and the sliding window for this question. Please feel free to pause the video to read the information here in some detail. Most importantly, as we sliding forward the window toward the end of the string, a character that is exiting out of the sliding window must be removed from the counter for the sliding window. For example, this character C must be removed in this counter. So from 1 to 0. With the background introduced, now let's write the code. So first of all, we will create the counter of, we call it the character counter for P. P is our target. Okay, so counter P initialized to be empty array with 26 items. Corresponds to the number of letters in lowercase English. Okay, and for I or for C in P, counter P ordinal C minus 97 plus equal 1. This is because ordinal A is 97. Okay, and here we have the counter P established. Next, we will create a similar character counter for the sliding window. Okay, so counter W initialized to be an empty array with 0 and 26 items. Then we're going to initialize the results array to be an empty array as well. And because the question asks us to return the starting indices, so we will have a 4 index in range length of S here. And then we're going to build our sliding window. So counter W ordinal as index and minus 97 plus equal 1 here. Okay, and then we need to take care of the boundary condition when the sliding window advance forward, and there will be previous character exiting out. Okay, so for example, let's say S is A, B, C, D, and P is just up like X. So we have the length of P equals to 1 here. And now we will see when we need to remove the previous character. So, or remove a previous character. Um, it's when the index is larger than or equal to the length of p here. So if index larger than or equal to length of p, then we know we need to update the counter w here. So which index? Removing, let's say index. The index is it's 1 here. Then we need to remove the 0 here. Okay, so we remove ordinal x index minus length p and minus 97, and importantly minus equals 1 here. Okay, and this is index at. Okay, so now we have the correct counter w, and then we can compare counter w to counter p here, but only when index is larger than or equal to length p minus 1 here. Why length p minus 1? Well, think about this example. When p is just 1 character, so length p is 1, and we can start comparing when index is 0. Okay, so that's why length p minus 1 here. And this part is also removing the item at index equal to here. Okay, equal to 0. And then so when counter w equals to counter p, we can append the starting index to the results array. And that starting index is index minus length p plus 1. And why starting index equal to index minus length p plus 1? Think about the situation when length p equals to 1, and there's a match at the first character, and index will be 0. So you want to have 0 minus 1 plus 1 equals to 0, and you append that index, and which will be correct. Okay, and finally we will return our results array, and that's our code for this question. And now let's submit the code to see how it works. We submit, it's pending, and done. It's pretty good. Okay, so finally we can analyze the code for complexity. So this code has the time complexity of all length of p plus length of s. Okay, since we need to traverse through both string using the for loop here. Okay, as we use two independent for loops to traverse through p and s respectively. Okay, and for space complexity, it will be O1. Since we use counter P and counter W, which have fixed length or fixed size, is 26 in each of them. And while ignoring the size of the resource array. Okay, so that's our solution for this question. This solution may appear to be a little complicated since we need to consider the index in different situations, but actually the logic is very straightforward. With some practice, you should be able to get a hang of it. So that's all for this video. Hope you find the video to be useful. Please feel free to subscribe for more videos. And I hope to see you next time soon. Goodbye.